In section 2.5, we're going to learn how to divide polynomial functions using long division and also using synthetic division. So two different methods for division. Remember in earlier sections we learned to add, subtract, multiply. Now we're going to learn to divide. And we're going to learn about the remainder and the factor theorems and what their use is in solving polynomials. So key vocabulary you'll need to know here is polynomial long division, right? Which is long division that is similar to what you've done before with numbers, but in this case we'll be using polynomials. And then synthetic division, which is essentially the same thing that you were doing when you did synthetic substitution. So a type of problem that we might solve with the skills in this section are a problem like this one, where we have a model where the profit P in millions of dollars for a shoe manufacturer can be modeled by this cubic function where P is equal to negative 21x cubed plus 46x, where x is the number of shoes produced, so millions of shoes, millions of dollars. The company now produces 1 million shoes and makes a profit of $25 million, but would like to cut back production. What lesser number of shoes could the company produce and still make the same profit? So what they're interested in doing is reducing the amount of work they're doing while maintaining the same amount of profit, which obviously makes a lot of sense. It would be better for that company to do. Later in the lecture we'll go through how to solve this problem, but for now let's get into some of the skills that are necessary to do this. So we want to learn how to divide. Okay, so we've already done adding, subtracting, and multiplying, and now we're going to work on dividing polynomials. And when we work with long division, which is what we're going to start with, it really looks a lot like the long division that you learned in grammar school. So you have x squared plus x minus 17 divided by x minus 4. All right, now this is a little different than what you worked with before, but what you would do in regular long division is you would estimate how many times your divisor would go into the item being divided, and then you'd use that number, and then you'd record the product, subtract to find what was left, bring down another digit, and then repeat the process until you're done. And that's essentially what we're going to do. But in doing this, I'm going to look really just at the first term here and the first term here. So how many times what do I multiply x by to get x squared? Well, I'm going to multiply it by x to the first power, and that's going to go here in the first power column. And then I'll take this and I'll multiply it times this whole thing. So x times x squared is x squared. And x times minus 4 is minus 4x. And then we subtract. X squared minus x squared is 0. And this is where it gets a little complicated. X minus negative 4x is 5x. And then I'm going to bring down the minus 17. And I'll repeat the process. What do I multiply x by to get 5x? I multiply it by 5. 5 times x is 5x. 5 times minus 4 is minus 20. And I subtract. 5x minus 5x is 0. Negative 17 minus negative 20 is plus 3. And now you can see that there's nothing I can multiply x by that's going to give me 3. So what I'm going to do instead is I'm going to take this and retreat to old skills that we learned. This is my remainder, and the remainder is expressed as a fraction over the divisor. You did this a long time ago. Later you moved into changing these into decimals because this was an integer and that was an integer, and you could. Here they're polynomials, so we can't. Okay, so it's got some parallels. It's a little different than long division that you're familiar with, but it does have some very distinct parallels, and you should be pretty familiar with how to do this. Here's another example, x squared plus 1, and I'm dividing that into 7x cubed plus 11x squared plus 7x plus 5. All right, so what do I multiply x squared by to get 7x cubed? Well, I'll multiply it by 7x, and that's going to go over here in x to the first power. So I'll have 7x times x squared. That's going to give me 7x cubed. And I'll have 7x times 1. That's plus 7x. And then I'm going to subtract, right? And obviously there's 0 x squareds here. 7x cubed minus 7x cubed is 0. 11x squared minus 0 is 11x squared. And 7x minus 7x is 0. And then I'm going to bring down the 5. And what do I multiply 11x squared by to get, what do I multiply x squared by to get 11x squared? Excuse me, I multiply it by 11. That will give me 11x squared. And 11 times 1 is going to be 11. And I subtract, 11x squared minus 11x squared is 0. 0 minus 0 is 0. And 5 minus 11 is negative 6. So my answer is going to be 7x plus 11 minus 6 over x squared plus 1. Okay, so it's pretty straightforward. You're doing division in a similar way to what you did with numbers and integers. And we're going back to the concept of having a remainder, which is going to go in as a fraction at the end as the numerator to a divisor. Okay, so pretty simple. Go ahead and get some practice on this. Do problems 5 through 7 in the workbook. Not the workbook, but in the textbook. And obviously this is not from 2.2, this is from 2.5. My mistake on the slide there. All right, when you're done with that, come on back. Okay, so here's a nice piece of information called the remainder theorem. We're going to use the remainder theorem along with a couple other theorems to make some advances in the types of problems we can solve and how we solve them in a little bit. But for now, I'm going to look at this, that if a polynomial f of x is divided by a binomial x minus k, then the remainder is r is equal to the function of k. Okay, that sounds a little confusing, but remember, when we talk about f of k, that means if I plug k into the polynomial. Okay, so in this case, when you look at this binomial, it's x minus k, so x minus 3. K in this case is equal to 3. Okay, and if I use synthetic division with this, then I know that my remainder will be the same number as plugging 3 into this. So I have 1x squared and I have 0x and 9 from the coefficients of this polynomial. I'm going to plug the 3 in. I add down, I get 1 times 3 is 3. I add down, I get 3 times 3 is 9. I add down, I get 18. Okay, so that's great. So I know the remainder is 18, so that would be 18 over x squared plus 9. But what's neat is that these are also the coefficients for the rest of my solution for dividing. So this would be x to the first power, x to the 0 power, and the remainder. So if you go from right to left, you have remainder, constant, and leading coefficient. And this is the same as if I divided. And if you want me to prove that here, we'll have x squared, I'm going to say plus 0x plus 9 just to make the division easy. And I'm going to do this with long division, x minus 3. What do I multiply x by to get x squared? I multiply it by x. X times x minus 3 is x squared minus 3x. And I subtract. X squared minus x squared is 0. 0 minus negative 3x is 3x. And I bring the 9 down, plus 9. And what do I multiply x by to get 3x? I multiply it by 3. 3 times x is 3x. And 3 times minus 3 is minus 9. And I subtract. 3x minus 3x is 0. And 9 minus negative 9 is 18. So my solution is x plus 3 plus 18 over x minus 3. Sorry, over here I wrote x minus 9. That was a mistake, right? That was what I was dividing by, x minus 3. Okay, so what this means is we can use Synthetic substitution is also synthetic division. So that exact same process can be done as long as I identify k appropriately. I can actually divide polynomials that way, and that's a lot easier. So if we go ahead and do this, let's practice a little bit. In this case, k is equal to 5, and over here k is equal to 2. I'm going to bring my coefficients down, 2, -7, and 10. I'm going to take my k value of 5. I add down. 2 plus 0 is 2, times 5 is 10. -7 plus 10 is 3. 5 times 3 is 15. And 10 plus 15 is 25. So this is, right, remember, remainder, constant, x to the first power. If I kept going in the other direction, I'd have x squared, x cubed, etc. But this is just 2x plus 3 plus 25 over x minus 5. Okay, and doing it with this problem over here, my coefficients are 4, -13, and -5. My k value is 2. Add down, 4 plus 0 is 4, times 2 is 8. -13 plus 8 is -5, times 2 is -10. And -5 plus -10 is -15. So I'll have minus 15 over x minus 2 of minus 5, and I'll have 4x. Okay, remember, if I'm dividing by a binomial with x to the first power, it's going to reduce the degree. My answer will be 1 degree less than what I was dividing. So it makes sense it goes from x squared to x to the first power. If you're keeping track, if you go from right to left, it's always the remainder, the constant, x to the first power, and I could have x to the second, x cubed, and on up, depending on how many terms I ended up having. Okay, so go ahead and practice synthetic division. Do problems 15 through 17 in the book, and then come on back to the lecture. Okay, so here's another piece of information, the factor theorem. And what this says is it takes it a step further, and it says if I go ahead and divide by this binomial x minus k, then x minus k is a factor if the function of k is 0, meaning if I have a remainder of 0. That's what this really means. When I plug the value of k in, my remainder, or my output, is 0. That means that x minus k was a factor. Okay, so this means I can use synthetic substitution, which is also synthetic division. I can use it to find factors by looking for inputs that have a remainder of 0. Okay, so one of the things we can do is if they tell me one factor of a polynomial, then I can find the other factors. If they give me 1, 0, right? Remember, the 0 is the k part of the factor. If they give me a 0 or a solution, right? Zeros and solutions are the same thing. So this gives me baby steps toward solving a polynomial on my own. Now I'll be able to solve a polynomial if I'm given a little bit of information, if I'm given one of the factors or one of the solutions. Okay? So here they're telling me for this polynomial, x minus 4 was a factor. So that means that, right, remember I'm looking at x minus k. So this would be x minus -4. So my k value is equal to -4. Okay? Now I'm going to do synthetic substitution, or synthetic division, whatever you'd like to call it. And I shouldn't be surprised at the results right now, because they told me if I plug -4 in, that I'm going to get 0 as a remainder. So I'm going to add down. I get 1 times -4 is -4. Add down. 6 plus -4 is 2 times -4 is -8. 5 plus -8 is -3 times -4 is 12. -12 plus 12 is 0. As promised, I got a 0 as a remainder. And here's what I have left. I have x squared plus 2x minus 3. So if you remember, I told you that at the end of the problems in Chapter 2, you have problems from Chapter 1. Now I need to factor this. So I want factors of 3 that have a difference of 2. Right? 3 and 1 are the factors of 3, and they do have a difference of 2. Because this sign is a minus, I know that I have a plus and a minus here, because a positive number times a negative number gives me a negative number. I know my firsts were x times x, and I know my lasts were 1 times 3. Now, it's important that the 3 has to be positive, so I have positive 3 and minus 1 will combine to give me positive 2. So the 3 goes here, and the 1 goes there, and the initial factor that they gave me was x plus 4, and now I'm fully factored. And it's one more step to say find the solutions. The solutions are negative 3, 1, and negative 4. They're the values of x that make each of these binomials equal 0. Okay, so another example, x minus 6, k is equal to 6 in this case. I'm going to bring my coefficients down, 1, negative 10, 19, and 30. When I plug 6 in, 1 plus 0 is 1, times 6 is 6. Negative 10 plus 6 is negative 4, times 6 is negative 24. 19 plus negative 24 is negative 5, times 6 is negative 30. Again, as promised, it ended up being 0. This is a quadratic function, a remainder of 0, so this is my constant. This is x to the first. This is x squared. So I have 1x squared minus 4x minus 5. Factors of 5 are the difference of 4. Okay, that's great. This is x minus 5 times x plus 1, using the same rationale I did in this problem. And then the original factor that they gave me was x minus 6. If I wanted to solve, my solutions are 5, 6, and negative 1. Okay, so go ahead and practice factoring the polynomial with a supplied factor. Problems 25 through 27. Come on back and we'll finish the lecture. Okay, so going back to our original problem, remember the key elements we have is we have profit is equal to negative 21x cubed plus 46x. But we're not interested in any old profit. We're looking for maintaining this profit of 25 million. So I know that 25, this is all in millions, is equal to negative 21x cubed plus 46x. And I want to solve for this, but I notice, right, one of my solutions is 1 million. Right? So first I want to put this all on one side of the equation, make it equal 0, because that's how we solve. 21x cubed plus 46x plus 25. I'm sorry, my mistake, it's minus 46x equals 0. And they've told me that one of my solutions is 1, so if I bring my coefficients down, I'll have 21. I'll have 0, because there's no x squared. I'll have minus 46, and I'll have 25. And if I bring down 1, 21 plus 0 is 21, times 1 is 21. 0 plus 21 is 21, times 1 is 21. Negative 46 plus 21 is negative 25, times 1 is negative 25. And this is 0. Okay, so now if I take a look at this, I have 21x squared plus 21x minus 25 is equal to 0. So now I want to go ahead and solve this quadratic function. And I have a number of choices, right? If I would want to look to see if it was factorable. Right, I have 1 and 21, 3 and 7. I have 5 and 5 here, and I would look at factors that would have a difference of 21. 35 and 15 don't have a difference of 21, they have a difference of 20. Right, so that doesn't quite work. If I want to go ahead, then I could look at completing the square or doing the quadratic formula. So that completing the square doesn't necessarily look too bad, but it's going to give some really weird fractions. Right, but we could, the big problem is it's going to be 21st. It's going to be kind of weird, right? So maybe I would want to put this in the quadratic formula. So I'm just thinking out loud here and how I might solve. I like the fact that when I divide everything by 21, this is going to become a 1. That's going to be 25 21st, which isn't going to be a lot of fun. But I think I'm going to go ahead and complete the square. So if I divide everything by 21, and I am going to add the 25 to the other side, that's going to be 25 over 21. And I'm going to take 1, divide it by 2, and square it. So 1/2 squared is 1/4. And that's going to equal 25 21sts plus 1/4. Well, maybe this wasn't such a great idea. I guess I'm going to get 80/4 for this. But that's not that bad. So 4 times 25 is 100. 80/4. Right, I'll have 100 80/4 plus 21 80/4. And that's going to be, right, 121 over 84. So that's not so bad. This guy factors to be x plus 1/2 squared. And if I go ahead and square root of the side, x plus 1/2 will be equal to plus or minus the square root of this guy. It is going to get a little weird. And then I'm going to subtract 1/2. X equals negative 1/2 plus or minus. Now the square root of 121 is 11. That's great. My numerator simplified out. Over the square root of 84. Well, I know it's 4 times 21. Right, so I can factor a 4 out. I'll get a 2 times 21. Negative 1/2 plus and minus, right? 11 over 2. If I'll have 11 root 21 over 42 when I multiply it by root 21 over root 21. Might have been easier to do the quadratic formula in this particular case. All right, so this would be negative 21/42. That's just converting the 1/2 plus or minus. Now this is important. Do I care about the minus? A negative number minus a number, it's going to be a big old negative number, right? Is it possible for me to sell a negative amount of shoes? I don't care, right? So I want a positive solution. I'm eliminating the negative solution because it's not possible to answer my question. So I'll have 11 root 21 over 42. So at this point, I'd probably whip out a calculator. I think I have one of those. Yeah, there's my calculator. So if I go ahead and do 21, the square root of 21, right, times 11 equals, and then divided by 42 equals 1.2 minus, open parentheses, 21 divided by 42, close parentheses, equals 0.7. So what that means is I can make, right, my solution is equal to 0.7. Remember, these were millions, so instead of 1 million shoes, I can make 700,000 shoes. Okay, 0.7 times the 1 million is 700,000 shoes. Okay, so it was a little awkward, a little unwieldy. We reviewed completing the square. We did synthetic substitution, synthetic division, and we went ahead and solved this particular problem.